Namaste everyone, it's me Shailendra. Welcome you to online monastic classes. We are doing first chapter of trigonometry for class 10, that is multiple angles. And so far we have completed up to question number 5. Today we will do some question number 6. That's long question. Let's start today class. Look the question number 6a. In LHS we have cos to the power 6a plus sine to the power 6a. When we are solving this type of question, we must have to look the RHS, which gives us idea what to do. Here, how can we write cos to the power 6a? There are two possible ways. Either we can write cos square a cube or cos cube a square. So which one we have to prefer? Here we have to prefer cos square a cube, so that wherever there will be cos square a plus sine square a, we can write it 1. So let's start. We can write this as cos square a cube plus sine square a cube. That's the formula of a cube plus b cube. We have two formulas for a cube plus b cube. One is factor formula, a plus b times a square minus ab plus b square. Another is a plus b whole cube minus 3ab into a plus b. We can use both. I will prefer here this formula, cos square a plus sine square a cube, that is a plus b whole cube, minus 3ab, that is 3 cos square a sine square a, into a plus b, cos square a plus sine square a. Now, in place of cos square a plus sine square a, it's 1. Here is whole cube. It is 3 sine square a cos square a, and again cos square a plus sine square a is 1. What's the final result we obtained is 1 minus 3 sine square a cos square a. Now what next? What to do? That if we look in RHS, there is 4 in the denominator, but here is nothing in the denominator. So if we need 4, let's multiply numerator and denominator both by 4. In denominator write 1 by 4. In denominator we have 4, so it is 1 by 4 now. And we can write this as 4 minus 3 into 4 sine square a cos square a. We have multiplied this with 4. So we have written this separately. Look carefully, that's the formula 2 sine a cos a whole square. So we have written in this way. Now we can write this as 2 sine a cos a whole square. And you know that that's the formula of sine 2a. So in place of 2 sine a cos a, we can write sine 2a whole square. What's the final result we got? 4 minus 3 sine square 2a. But look in the RHS. In place of sine square, we want cos square. We have learned the square formula. In place of sine square, we can write 1 minus cos square. Do the simplification. 4 minus 3 plus 3 cos square 2a. What's the final result we obtained? 1 plus 3 cos square 2a, that's the RHS proved. That's the formula of AQ plus BQ we have written here. Then write the formula of A plus B whole cube. And wherever there is cos square A, sin square A, we have written 1. If we look in RHS, we want 4 in the denominator, but there is nothing in the denominator. That's why we have multiplied numerator and denominator with 4. In denominator, we have written 4, and in numerator, we have multiplied whole with 4. Then this is in the form of 2 sin A cos A whole square. That's the formula came. And finally convert sin square into cos square. In this way, we have completed 6A question. Question number B, almost the same. That's cos 6A minus sin 6A. What's the changes you have noted there? In place of AQ plus BQ, now it is in the form of AQ minus BQ. So we can write this as cos squared A whole cube minus sin squared A whole cube. Again, we have two formulas for AQ minus BQ. Which one we will prefer? As earlier I have told, we can use both, but I will prefer here the factor formula because we want cos 2a, and this will be the form of, this is the formula of cos 2a. A minus B, we have written cos square A minus sin square A square plus B square plus AB, that is cos square A plus sin square A plus cos square A sin square A. We have formula of this. Now we can arrange this in the form of A square plus B square. So we can write cos square A whole square plus sin square A whole square plus cos square A sin square A. Now it's the formula of A square plus B square. What's the formula? Again we have two formula. A plus B whole square minus 2AB or A minus B whole square plus 2AB. But we want one here. For this one, we have to use A plus B whole square minus 2AB. Rest is written same. Now, you know the formula of cos square A plus sin square A is 1. Do the subtract. It came cos square A sin square A. And finally, we got the result 1 minus cos square A sin square A. But in RHS here we want 4 in the denominator, but here is nothing. You know the process. How can we make 4 in the denominator? Multiply numerator and denominator both with 4. In RHS you need here sin 2a whole square. Look carefully. If we write this in the form of 2 sin A cos A whole square, that's the formula of sin 2a. And sin 2a whole square is sin square 2a. That's what we have to prove. Exactly the same as question number 6a. Now in question number 6c, cos to the power 8a plus sin to the power 8a. That's in the form of a square plus b square. We can write this as cos to the power 4a whole square plus sine to the power 4a whole square. Which formula now we have to use for a square plus b square? Either a plus b whole square minus 2ab or a minus b whole square plus 2ab. So when we look there, in power 4 we need plus here. So we must have to use a minus b whole square plus 2ab. That's again in the bracket you have a square minus b square. This we can multiply numerator and denominator with 8 because you want 8 there in the denominator. In the bracket that's a plus b and a minus b. Cos square plus sine square a, cos square a minus sine square a whole square, and it came 1 by 8 into 16 sine to the power 4a cos to the power 4a. That's the formula of 1. Cos square a minus sine square a is the formula of cos 2a. And here we want sine to the power 4 to a. So look carefully. We can write this as 2 sine a cos a whole to the power 4. Do the square. Cos square 2a plus 1 by 8 sine 2a whole to the power 4. In place of cos square, we want 1 minus sine square. You know the formula of cos square, 1 minus sine square. When it is 2a, 1 minus sine square 2a plus 1 by 8 sine to the power 4 2a. That's the RHS proved. So we must have to remember these points. Why we are using a minus b whole square plus 2ab, why we have to use a plus b whole square minus 2ab. You can write in place of this a plus b whole square minus 2ab, then again you have to change, again in bracket you have to apply the formula double, repeated, same thing will be repeated, then you will come to this formula. That's why you previously know, you must have to know which formula we have to apply there. Now come to the question number D. Here cos cube a cos 3a sine cube a sine 3a. We have the formula of cos 3a and cos cube a also. We have learned 4 cos QA formula, 3 cos A plus cos 3A. If there is no 4, in place of 4 we can write there. So we have cos QA formula 3 cos A plus cos 3A by 4. Same way, sine cube A formula is 3 sine A minus sine 3A by 4. We can utilize the formula of both. Which one we have to prefer? In such type of question where there is cos cube and cos 3, I will prefer the formula of these two. The cos QA formula is 3 cos A plus cos 3A by 4 into cos 3A plus sine QA formula is 3 sine A minus sine 3A by 4 into sine 3A. Now take the LCM 4, then do the multiply. 3 times cos 3A into cos A plus cos square 3a. 3 sine 3a into sine a minus sine square 3a. Now we have to group. Look there, both have 3, both have a square. Take the 3 common. It's came cos 3a into cos a plus sine 3a into sine a. And group these two. Cos square 3a minus sine square 3a by 4. Now look in the bracket. What are they? That's in the form of cos a cos b plus sine a sine b, which is the formula of cos of a minus b. Inside the bracket, this second bracket, that is cos square a minus sine square b. Cos square a minus sine square a, that's the formula of cos 2a. Here it came cos 2 into 3a. Do the simplify. Here cos 2 3 just 6 came. We want the result in 2, but here is 3, so we can write 6 as cos 3 into 2. If we multiply these two, 6 came. Here if you do multiply, again 6 came. Now we can write the formula of cos 3a there. 3 cos a plus. What's the formula of cos 3a? It is 4 cos cube a minus 3 cos a. 4 cos cube. In place of a there is 2a minus 3 cos a by 4. These two cancelled. 4 cos cube 2a by 4. 4 cancelled. It came cos cube 2a equal RHS. That's the proof completed. Question number E. 4 sine a into cos cube a minus 4 cos a into sine cube a. What's common there? 4 sine a cos a. What are the remaining factor? Cos square a minus sine square a. In RHS we want the result sine 4a. Now we can write this as 2 sine a cos a. We want formula. We have the formula of this. That's why we have arranged in this way. And that's cos 2a, this whole. Now this came sine 2a, cos 2a. Again you have formula 2 sine a cos a. The sine 2a, but in place of a there is 2a. So sine 2 into 2a is equal to sine 4a. That's the proof completed. Question number F now. 4 sine cube a cos 3a plus 4 cos cube a into sine 3. Almost the same as question D. Both are same, but there is cos, here is sine. So what to do? In such question, I have told you I will prefer the formula of this. The 4 sine cube a formula is 3 sine a minus sine 3a into cos 3a plus 4 cos cube a formula is 3 cos a plus cos 3a into sine 3. Now what we can do? Do the simplify, do the multiplication. 3 cos 3a into sine a minus sine 3a into cos 3a plus 3 sine 3a into cos a plus sine 3a into cos 3a. These two are exactly the same, but sign are different, so these two cancelled. In these two we can take common. Cos 3a into sine a plus sine 3a into cos a. This is in the form of cos a cos b plus sine a cos b, sine a cos b plus cos a sine b. We can write this as formula of sine 3a plus a, and sine 3a plus a is 4a. That's the proof we have completed. Now come to the question number G. In question number G, here is cos 4a. We want the result in cos, but we want the result in cos a, but here is 4a. So first of all, we can convert 4a into 2a. We have formula 2 cos a square a, that is 2a minus 1. We can write this as cos 2a whole square. We have to convert 2a into a, or which a? Cos a. So we can write cos 2a as 2 cos a square a minus 1 whole square. Now inside the bracket, a minus b whole square. So you can write a square minus 2ab plus b square minus 1. To the simplification, 4 cos a square a plus 1 minus 1. Now what to do? Do the multiply. 4 to ja 8 cos a square a plus 2 minus 1. Finally, what the result we obtained? That's the RHS. We have completed up to question number G. Now in question number H, here is sine 5a. Question number H, we have sine 5a. We have to convert this in a. We can write 5a as 3a plus 2a, because we have the formula of sine 3a cos 3a all. We can write sine a cos b plus cos a sine b. So wherever a it came 3a and wherever b it came 2a. Sine of a plus b formula. Now we have to write the formula. If possible, we want all the result in sine. So if possible, write the formula in sine. If not, so what's the formula you have? You can, the sine 3a formula is 3 sine a minus 4 sine cube a. That's already in sine. Cos 2a formula we have 1 minus 2 sine a square a. That's again came in sine. But cos 3a you have formula 4 cos cube a minus 3 cos a. And sine 2a formula 2 sine a cos a. Let's multiply 3 sine a. 3 sine a minus 2, that is 3 to ja 6 sine cube a. We have multiplied both with 3 sine a. Now with 1 first, minus 4 sine cube a into 1 minus 4 sine cube a. 4 to ja 8 sine to the power 5a. Here 4 to ja 8 sine A into cos to the power 4A minus 3 to the 6 sine A into cos square A. Here, whatever the result we have obtained after the multiply, which one are not in sine? These two. All are in sine, but we want all of them in sine. So where there is cos square A, we can write 1 minus sine square A, then it will be in sine. Here it is cos 4A, so we can write cos square A whole square. Then cos square A formula 1 minus sine square A whole square, then we can convert. Here 3 sine A, so write 3 sine A. These two are like term. Minus 6 minus 4 minus 10 sine cube A plus 8 sine to the power 5A. Here 8 sine A into cos square A whole square minus 6 sine A, and in place of cos square 1 minus sine square A. 3 sine A minus 10 sine cube A plus 8 sine to the power 5A plus 8 sine A, and in place of cos square you can write 1 minus sine square A whole square minus 6 sine A minus minus plus 6 sine cube A. Now 3 sine A minus 6 sine A minus 3 sine A minus 10 sine cube A plus 6, sum of these two, minus 4 sine cube A plus 8 sine to the power 5A, 8 sine A, and write the formula of A minus B whole square. A square, 1 square is 1, minus 2AB, 2 into 1 into sine square A, 2 sine square A plus sine to the power 4A, minus 3 sine A minus 4 sine cube A plus 8 sine to the power 5A. Now do the multiply, plus 8 sine A minus 16 sine cube A plus 8 to the power sine to the power 8 sine to the power 5A. Now do the calculation final. These two, sum of these two came 16 sine to the power 5A, minus 16 and minus 4, minus 20 sine cube A, 8 sine A minus 3 sine A, it came plus 5 sine A. That's the RHS we have proved. First of all, for 5A we have written 3A plus 2A, then we have written the formula of sine of A plus B, then we have written the formula of sine 3A cos 2A cos 3A sine 2A. Whatever the result we obtained after the multiplication, we want all the result in sine. Where there is no sine, it came cos square and cos 4A. We know the formula of cos square A is 1 minus sine square A. So we have written cos 4A as cos square A whole square, and where there was cos square A, we have written 1 minus sine square A. Now do the simplification. What's your final result obtained? That's your RHS. We have completed question number H. I, J, K, all the three are same. I will prefer, either we can do from LHS or RHS, both way we can do, but I will prefer RHS. Generally in proof, not necessarily in all, generally in proof we take the bigger parts where more thing is given instead of the list. So here 2 cos A minus 1, 2 cos A plus 1, 2 cos 2A minus 1. When we are solving the problem like this in trigonometry, what we can do, we must have to do like algebraic work. I am saying that is here it is in the form of A plus B, A minus B, and you know its multiply will be a square minus b square. So do this thing. Now you don't have the formula of 4 cos square a, but you have the formula of 2 cos square a. So you can write 2 multiply 2 cos square a. What's the formula of 2 cos square we have? It is 1 plus cos 2a. Rest you know better. Do the multiply. Do the simplify. What you got? Again, it's in the form of a plus b, a minus b, so it is a square minus b square. Again, do the same process what we have done earlier. Again, it will be the formula. It is 1 plus cos 2a, but here in place of a is 2a. Do the simplify. Now finally solve this. What's the result we got? That is 2 cos 4a plus 1. That's our result. But now you can do question number I, J, K because all these three are same. Now come to the question number L. L and M are same question. In LHS, it is 2 plus 2 cos 4 theta. We want the result in cos theta. First of all, we can convert 4 into 2. We want the result in cos, so write the formula in cos, that is 2 cos square 2 theta minus 1. We have written the formula 2 cos square 2 theta minus 1. Do the multiply with 2. These two cancelled. Now it came 4 cos square 2 theta. Square root of this is 2 cos 2 theta. Again we can write the formula of cos 2 theta. 2 cos square theta minus 1. Do the same process. Do the multiply. These two cancelled. 4 cos square theta is equal to 2 cos theta. That's our result. What we have done, in place of cos 4, we have converted this into 2. So written cos 2 into 2 theta. It's the formula of cos 2 theta. So write it 2 cos square theta minus 1. But in place of theta, we have written 2 theta. Do the multiply. Then find the square root of this. And again apply the formula of cos 2 theta. Do the simplification. That's your result. Question number L and M are exactly the same question. Now question number N and O are same. Question number N. Cos square A plus sine square A into cos 2B. Look in RHS. We want cos square B plus sine square B and cos 2A. Here, what I will prefer, we have many formulas of cos. Which formula we have to apply here? I will use such formula like I have written 1 minus 2 sine square B. Question arises why? When you do the multiply, the result what you obtained, look there, cos square A plus sine square A become 1. That's why I will prefer such formula so that after the separate part, these two became 1. But here, we want sine square B, but we want cos 2A. So in place of 2 sine square A, we can write the formula 1 minus cos 2A. Now do the multiply. 1 minus sine square b minus minus plus cos 2a into sine square b. And you know 1 minus sine square b is cos square b plus cos 2a into sine square b. That's RHS completed. In place of cos 2b, what I have told you, we will prefer such formula. After the simplification, we will cut cos square plus sine square a so that we can write 1. And here you want sine square b, but you don't want this. In place of this, you want cos 2a. So write the formula of 2 sine square a and do the simplification. Now we have completed these two. Question P, Q, R. All these three questions are same. Question number P. In RHS, we want the result in cot, so we can convert tan into cot. Here it was 3a. Cot 3a plus 1 by cot a minus 1 by cot 3a plus cot a. Take the LCM. Cot 3a, cot 2a, cot a plus cot 3a minus 1 by cot 3a plus cot a. Now in divide, we have to write the reciprocal. It came cot 3a by cot a plus cot 3a minus 1 by cot a plus cot 3a. Both of them have same denominator, so in LCM we have cot a plus cot 3a, and in numerator it is cot 3a into cot a minus 1. Now that's the formula. Which formula we have? Cot a into cot b minus 1 by cot b plus cot a. That's the formula of cot a plus b, and it came cot 4a. Question P, Q, R. All these three are exactly the same question. So now we will do the question number 7. In 7a, given tan a is equal to x by y, we have to prove y times cos 2a plus x times sine 2a is equal to y. When we have value of tan a, we will write the formula of cos 2a and sine 2a in tan. That is 1 minus tan square a by 1 plus tan square a. Here it is 2 tan a by 1 plus tan square a. Both of them have same denominator, so we can write 1 plus tan square a. Y into 1 minus tan square a plus 2x tan a. Now we can substitute the value of tan a. The tan square a value will be x square by y square. Here in place of tan a x by y, here again x square by y square. Take the LCM. Y square minus x square by y square plus 2x square by y. Here it came y square plus x square. Take the LCM. Y square y cube minus x square y plus 2x square y into y square by x square plus y square. Now do the solving. Y cube plus x square y by x square plus y square. Y is common there. We have completed question number 7a. Now in question number 7b, it is given 2 tan A equal 3 tan B. Therefore, tan A equal 3 tan B by 2. Why we have find the value of tan A? Because we want the result in B rather than A. In LHS we have tan of A minus B. Write the formula. Tan A minus tan B by 1 plus tan A into tan B. Substitute the value of tan A. 3 tan B by 2 minus tan B, 1 plus 3 tan B by 2 into tan B. Do the LCM, do the simplify. It came 2 tan B by 2 plus 2, 3 tan square B. Finally, we got tan B by 2. Here, 3 tan B minus 2 tan B is tan B, and in denominator it is 2 plus 3 tan square B. So what we obtained, when we look in RHS, we want the result in sine and cos. Here it is in tan. Now convert tan into sine and cos. So in place of tan beta we have written sine beta by cos beta, and in place of tan square we have written sine square plus cos square. In denominator we have to take the LCM, that is cos square b, and it came 2 cos square b plus 3 sine square b. Now you know how to do the divide. Write the reciprocal of the denominator parts. It came 2 cos square b plus 3 sine square b. Sine b into cos b. We can convert both of them into same, either in cos, either in sine, or without doing this also we can do, but I would like to convert them into cos. Sine beta, cos beta, 2 cos square beta plus 3 minus 3 cos square beta. What's the final result we got? That's it. But look in RHS, we want sine 2 beta in numerator. We came close to it. It is sine beta cos beta, but we want 2 so that it will be in the formula. So multiply numerator and denominator by 2. After the multiplication, we got the result this. You can write 2 sine beta cos beta sine 2 beta. And in place of 2 cos square beta, we want the result cos 2 beta. So we can write 1 plus cos 2 beta. Do the simplify, that's your result. Let's start again from the beginning. First of all, we have find the value of tan A. In LHS, it is tan of A minus B. Write the formula. Wherever there is tan A, substitute the value. Then do the simplify. Final result you obtain this. But we want the result in sine cos, so convert 10 into sine cos. Finally, we got up to result this. Here is the result. Then, when you look carefully in the RHS, you want sine 2 beta. For this, you want 2 in the numerator. That's why we have multiplied with 2. In upper part, we got sine 2 beta. And now in denominator 2 cos square beta, we have to convert this into cos 2. So write the formula. That's your result. Now finally the question number 8. Question number 8a. First of all, give him cos a equal 1 by 2a plus a. 1 by a. In question a in LHS it is cos 2a. We can write the formula 2 cos a square a minus 1. Here the value of cos a is given, that's why we have written the formula in cos a. In place of cos a square a, we can write the value 1 by 2a plus 1 by a whole square. Now do the simplify. 1 by 2a square is 1 by 4. And a square plus 2ab plus b square. We have written the square of this and this both. 1 by 2. We want the result this, so making a group of a square plus 1 by a square plus 2. If we multiply this whole with 1 by 2, 1 by 2 a square plus 1 by a square, and 1 by 2 multiplied with 2 is 1. These two cancelled. That's your result. 1 by 2 a square plus 1 by a square. That's the RHS we have completed. And in question B, in place of cos 2a, it is cos 3a. So what's the formula of cos 3a we have? 4 cos cube a minus 3 cos a. Now put the value of cos a. Now write the cube. 1 by 8. 1 by 2 cube is 1 by 8. And it's the a cube plus b cube. So write the formula a cube plus b cube plus 3ab into a plus b. These two cancel. Make the group plus 3 into a plus 1 by a. Put the value. Now do the multiply. That's your result. Look again from the beginning. We have the value of cos A and we want to find the value of cos 3A. We have formula of cos 3A. Write the formula. Then substitute the value of cos A. After substituting the value, we have simplified. 1 by 2 cube is 1 by 8. And a plus b whole cube formula, a cube plus b cube plus 3ab into a plus b. And it is multiplied 3 by 2 a plus 1 by a. Then do the multiply and do the solving. That's your result. With this, we have completed first chapter of trigonometry in class 10, that is multiple angle. In coming class, we will learn sub-multiple angles problems.